So cloud best practices and gotchas. I almost started this off with just don't for cloud, which is maybe being a bit facetious, but I think if you aren't experienced in the cloud, don't try to jump in yourself. The cloud is huge, and there's a lot of places where you can get help. So first, start getting into the cloud by getting into the cloud without actually looking at or thinking about the cloud. So work out your data access patterns in a Jupyter Hub environment that's managed by somebody else. So Open SAR Lab is a great community if you're doing SAR processing and tools. You can get help on your algorithms and develop things. There's this community built around it. OpenScapes is a really good other environment that's broader than SAR. It's kind of across the whole NAS, the DAC ecosystem and things. So there's Jupyter Hubs and tutorials to work through there, and a Slack community to be engaged in. There's the NISAR community workshop to help with those kind of things. And if you're an IC scientist, CryoCloud is another good opportunity to get kind of not only into the cloud in an environment that's in the cloud to work out the data access patterns, but also a community of people that work in the cloud. If you're really just looking to run Python codes and functions in the cloud, but not really scale in a high throughput sense or run these standardized workflows with hype, and are really in just exploratory analysis space, using the DAS gateways that are connected to these Jupyter Hubs, or Coiled, which lets you fire compute into your own AWS account without thinking about the Docker part of it, are really good options. Running through, once you start to actually really scale in high throughput computing and want to maybe build your own stuff and use your algorithms like into infrastructure you've built, or at higher rates than you can get with Dask or Coiled, you're really going to look towards things like hype and different things like that. And so use the tooling like the cookie cutter to build your first container to make it easy and get in there, play around, do that kind of stuff. So once you actually go to start building in the cloud, I can't emphasize enough how it's my last bullet point because I'm going to come back to it again, but find a good cloud engineer and work with them. Everything will be faster and easier if somebody can help you through the just massive amounts of things to learn in the cloud. So as always, like with anything like this, start small, break things down into the smallest parts you can. If you're going to start in the cloud, just make a few Lambda functions in AWS. These are just simple. It's a Python script that does something. You just send the package, the script itself, into Lambda. You don't even have to think about anything else, and watch it execute. Maybe run a container that we built with a service like AWS Batch that you just say, hey, run this Docker command on this instance, and it just does it for you, and the product's upload to X3 and you see it succeed. Build maybe a simple API using like API Gateway and these kind of tools that you could post a parameter to, and then it writes it to S3 or something really simple. And you can kind of see the response to that. And then you can start piecing these things together, but always piece them together small. So take your API gateway and have it fire a Lambda function, and that Lambda function then fires a container and those kind of things, and start chaining them together. And once you start to get a feel for how permissions work and services work and how you chain things together, that's when I think you can start thinking about, okay, how do we want to really build whatever we're after, these kind of workflows. And everything, like I said, will be easier if you can find a good cloud engineer and work with them. That's the power of these Jupyter Hub communities, is that there are really good engineers in there. Some of them, sometimes like in OpenScapes and CryoCloud and those Slack communities, you have, you can ping the founders of Jupyter, like the people who created IPython and Jupyter themselves are sometimes in there, and those kind of things. You can really get some expertise on hand to help you in this very nice co-development model. In AWS especially, docs are really, really good but really dense. Most really good cloud engineers are really good because they can read the docs well. Like one of our best cloud engineers here, Andrew Johnston, is always like on the docs immediately, finding you the section of the docs that explain exactly what you want and handing it to you. Like most of the times he is just a AI assistant to get you to the right docs. So I can't emphasize enough, read the documentation, love the documentation, read the documentation. So when you're in the cloud, the major thing that you have to deal with that you don't think about as much of or deal with as much locally or on-prem is failures. Everything in the cloud breaks all the time. The primary mode of cloud operations is failure. And I say that a little bit facetiously because the uptime is incredibly good for services like S3 and cloud services in general. You likely can't build something more resilient and up more than AWS can, but everything connects through APIs. APIs go down, one API goes down, entire systems go down. A problem in US East 1 causes problems across the global community, including sometimes you can't use your vacuum because there's an issue in AWS US East 1. When you start getting to scale, you start to stress APIs. You tend to do things and not in API friendly ways, so you hit them really hard. More than necessary, sometimes you can reorchestrate workflows to be nicer to APIs. So you start getting rate limits and throttling or 500 errors because you just crashed somebody else's API for them. So you really have to make a concerted effort to think about retries and strategies. For intermittent outages, using an exponential backoff is really nice. So you saw a failure, maybe that was just a weird network interruption, maybe it's just an intermittent outage. So let's try it again in a second. Oh, that didn't work. Okay, let's try it again 4 seconds later. Oh, that didn't work. Okay, now let's try it again like a couple minutes later. So that just giving systems time to recover in that strategy. If you're using the spot market, which is the cheaper instances where AWS can interrupt your workflow if they want to, your benefit there is that you get 1/3 the cost for compute, but you're likely to get interruptions. And the longer the process runs, the more likely you are to get interrupted. So those, in general, the average rule is spot instances cost 1/3 the on-demand instances. So if you end up needing more than 3 retries, you probably were better off just using on-demand if the retries are primarily driven by interruptions. So there's some trade-offs with costs and interruptions and how you handle them. But if you're handling retry strategies well, you can take advantage of these significant cost savings. And so when you get into doing this stuff, and now you're needing to think about things failing, retry strategies, how do you handle all this kind of stuff? You really want to start thinking about workflows. Even just running the container is more than just a Docker run at this point. It's a Docker run, oop, it failed, catch the fail. If it's this kind of failure, try it again. If it's this kind of failure, wait, and then try it again. You know, those kind of things. So workflow managers really help with that. If you're a computer science person, you're going to hear the terms directed acyclic graph or state machine to mean workflow manager. There's subtle differences, but that's the CS speak for that kind of a thing. So AWS step functions or state machines that allow you to map kind of workflows. That's actually what we use at Hype right now. They're cheap. They're easy-ish, annoying to write, but it built in. There's also Airflow and Prefix, a modern take on Airflow, which are often targeted towards machine learning type algorithm or type workflows and that kind of stuff. Those are DAGs, and they work really well for that. You can do these kind of workflows in Python that way. And then if you're in the supercomputing world, there's also things called HT Condor for really managing that high throughput type of computing on HPC systems and grid computing networks. And there are a bunch of others. These are the big ones that I think are worth looking at. So anytime you start building in the cloud, there all of a sudden is a lot to manage in the cloud. You've got your code, you've got CI/CD pipelines, you've got deployments. Once they're deployed, you've got operations, and then all that ends up with billings and payments. So the smaller you are of a team or the group you are, and often in grant projects, you're maybe a few people, you really want to make as much of that someone else's problem as you can. So this is where managed services come in. AWS provides the service for you. They do all the provisioning, updates, security. They're going to have better uptime than you can, almost always. And the trade-off there is that they're often limited capabilities, so they're not as fully featured as running that service that they're managing for you, but you also need limited knowledge to use it. So instead of running your own Kubernetes cluster, you can use the Elastic Kubernetes service. Instead of running batch processes of your own container runs, you could use AWS Batch. And then serverless is a managed service that's built on an as-used basis. So the major difference here is that it auto scales for your workload, and it should scale to 0. If it doesn't scale to 0, it's not serverless. It's just a managed service in pretty branding. So the thing that's really nice about serverless is that scaling to 0, a lot of science workloads, almost all of them are intermittent, where you're kind of off in your own world doing algorithm development, refining, validation, and then you want to scale out or run a test, and you're like, okay, and so there's a big burst of processing. And then you go back and do that refinement path, and then a big burst of processing, and then you're happy, you're ready to make products, and then there's a massive burst of processing. So these kind of intermittent workloads are ideal for something that when you're not using it, doesn't charge you money. So that's what scale to 0 means. So scaling to 0 cost. So if you're using AWS Batch, for example, that's just a service that you Docker run a container. You only pay for it while the container's running. Once the container's done running, there's no instances living or anything like that. It's done. So you only paid for the actual usage you used. So those are really worth looking into. To use them, though, you have to really, this is where re-architecting and adopting a cloud native model comes in. So sometimes taking advantage of the serverless model will require re-architecting for the cloud. That does tend to mean that lift and shift is possibly the most expensive way to do something. So if it runs a certain way on-prem or on your computer and that works, you can often just pick that up and put it in the cloud, looking almost exactly like your on-prem service, but you won't be taking advantage of any of the things that really make the cloud. And so then you're possibly going about it in the most expensive way possible. So often cloud migration should be coupled with quite a bit of engineering effort. But there's often resistance at a lot of levels to managed services. The theory is that managed service make it harder to migrate clouds or in or out of the cloud. I generally don't buy that. Personally, this is a very personal recommendation here. It's generally more costly in time and money to worry about at the scale of most science projects. The amount of migration you're going to have to do isn't very large. You're not building these massive infrastructure projects. And the key to kind of this being reality is you can use, like, if you use their services to run your stuff, great. Like, those are managed services. There's probably an analog somewhere else. But don't make their services your stuff. So what I mean by that is don't use proprietary data formats. Like, keep Docker and as like the backbone to preserve the portability and keep everything kind of open, reproducible, and portable, but go ahead and stuff all that stuff in managed services so you don't have to think about them. But once you get into proprietary data formats and these kind of things that you actually can't migrate out, then vendor lock-in becomes a real worry. Even if you're using Terraform, though, that is kind of cloud agnostic, the providers are different. You're going to have to completely refactor your infrastructure as code to go from one cloud provider to another cloud provider. Often services don't have direct analogs across clouds. So there's even just a cloud agnostic lift and shift doesn't always work out. So I think vendor lock-in is something that is not worth worrying about generally. For budgeting and cost monitoring, cloud is always charged for usage. You always are charged for whatever you did. So you really need to watch really hard what you're doing and where you're going. So cloud providers always provide good ways to set up billing alerts and to analyze budgets. The AWS Cost Explorer is your friend. If there's one thing to learn in AWS, it's that. It will tell you everything about what you're spending, how your resources are used, all of that kind of stuff. And it lets you set up budgets and even project budgets out into the future if your spending is predictable. Institutional policies, however, may muddy the waters. Not every institution just takes the cloud bill that Amazon sends them for your account and gives it directly to you. Sometimes they have discounts. Sometimes they have quite a few things that could go into the bill, and whether they pass those things on to you or not, or use them to fund their IT infrastructure, is up to the institution. And at certain institutions, they don't even match the billing cycles to what they charge your projects. So it can be confusing to go from what you see in the Cost Explorer to what you see your institution charging you, if your institution is managing your accounts. The Cost Explorer will still be the most informative of what's actually happening in AWS, not what's happening in terms of your institution. The biggest best practice for billing and budgeting and cloud estimation that I could emphasize is AWS accounts are free. You can make a bajillion of them. It doesn't matter. So put one thing in one account. That makes it really easier to separate charges. If you have a Jupyter Hub for production and a Jupyter Hub for test, put them in separate accounts. Then you can see how much you're spending on tests, see how much you're spending on production. If you have another application you're building on top of it, put it in its own account. And then you can really actually analyze costs really well that way. And you can analyze costs across accounts as well if you set up the permissions. So you can still see grouped high level total costs. You can separate costs based on tags. They sort of work, but it's really hard to tag everything and actually get charges allocated well with tags in my experience. So I generally don't recommend them unless you can't break them out into separate accounts and you need to deal with tags within an account. And then similarly, there are these things called crowd credits, a gift card that you can get in various mechanisms. When they get applied to an account level. So if you have multiple projects using the same account, those projects will eat those cloud credits. There's no way to break it out lower than the account level. And to emphasize again, ask for help. Find someone who's good with the cloud who can walk you through this kind of stuff. Each institution typically has an AWS account rep that is there to answer these kind of questions. They are good at answering billing questions and helping you with billing. So don't ever be afraid to ask for help. So I do want to just spend a couple of minutes poking at the Cost Explorer. I won't do too much, but I just want to show you what it looks like. That's okay. So I'm just going to jump into a random hype deployment. And go to the billing and cost management. AWS's search bar actually works really well if you just type cost explorer. Billing and cost management comes up right there, and it says one of the features of it is cost explorer right there. So you can just click there. This drops you into cost explorer. So here's our overall costs. You can select a date range. This date range can be quite large. You can go year to date, past 3 years. If you wanted, we'll just look at the last year. We got most of the year. And I can even predict out the future a couple of months if I want to. So this has been the overall spending that we've had in terms of dollars a month. And based on this usage pattern, AWS says, hey, you might want to predict kind of this much spending in the future. The granularity can be pretty high. You can go even daily if you want, which for such a long date range doesn't help, or down to hourly if you're really looking in on stuff. One of the caveats with the Cost Explorer is that it takes 24 hours for billing information to hit. So if something's actively running, it might take 24 hours to show up. You can group by service, which is nice. So right here, you can see for hype, EC2 instances, compute cost is the most that we spend on. That's the blue. And then S3 is the second amount. And then basically everything else is in these small little other bars. So hype itself is pretty like predictable in that compute and storage are easy to predict for managed workflows. So we can actually guess and estimate hype costs very well because of that. It sort of lets you look at everything that you could ever want. You can include, exclude specific services. So you could include only EC2 if you wanted to, or just EC2 and S3. If you want to look just at the different instance types you're using, you can actually break instance charges down by the instance types and how often you're using them. So we're often using our 6 family of instances of various sizes. And you can see how that allocation changes over time. One of the things with costs that is worth noting is that sometimes your institution has refunds or credits or these kind of things, and that can mess with the thing. So you often want to only include usage here. And that gives you kind of a better idea of what your usage is, as opposed to what your bill is. And in this same area, you can set up budgets on this sidebar, and budget reports to automatically email you budgets. There's a cost optimization hub, which is pretty new, that you can play around with to help you kind of figure out these costs. So that's probably enough of the cost explorer, but as you get more and more into actually doing stuff in the cloud and building stuff in your own accounts, the more and more you want to get familiar with this. This will be your most powerful tool to understand what's happening. So budgets are hard to do because they're usage based, and sometimes it's hard to predict usage. So it's best to do a little bit, monitor the costs, take a break, get yourself a nice little gap in the billing window, do a little bit more, monitor the costs, take another 24-hour break, get a little daily gap there, and then start thinking about how to project or how to do a little bit more. And that's going to be the best way to get yourself an accurate estimate. Unfortunately, grant projects always want you to estimate on like a 3 to 5 year cycle, which is kind of ridiculous for cloud costs. So the farther out you go, tack on more and more padding. You can be very accurate within a year. Beyond a year, I think you're getting a little fuzzier, sort of a thing. AWS provides that calculator, calculator.aws. It is really powerful. You can build kind of any budget scenario you can imagine in AWS in that calculator and predict budgets and costs and everything. If you go to apply for cloud costs, you're going to have to provide a calculator link that shows the costs you expect. But because it's so powerful, it's pretty complicated. The more you're familiar with the billing console and like how things show up in the bills, the easier it is to use the AWS calculator. So they sort of go hand in hand. But you really can't beat experience if you don't have experience in the cloud, whether it's with your type of workflows or just billing or experience. Find someone who does to help you with that part. It's like billing alone itself is a whole career worth of learning in the cloud. So don't feel like you have to know everything as you go into the cloud. So some tools to keep costs down is most science workflows break down like data and compute and then other stuff. So this is not services, this is like science workflows. So the key metrics for data are gigabytes and how long you keep the file. So the more you're able to lifecycle products that you don't need. So it may be intermediate products from processing that you put in S3 for time, things you stage to be input data for a chunk of processing, that kind of stuff. If you delete or life cycle them out, then you're not paying for them anymore. And there's a lot of tooling to set up these lifecycle rules in AWS so that you can have that happen automatically. You can tag a file a certain way, and then after a certain amount of time, that type of file goes away. So that's a really good way to keep S3 costs down. I highly recommend S3 intelligent tiering. It's sort of a set it and forget sort of thing. It costs a little bit to move data into intelligent tiering, but instead of always paying the standard S3 rate, if the data doesn't get touched very often, it slowly migrates down into lower storage tiers. So you actually get charged less for the data that haven't been touched for a long time. The caveat being is if it gets touched, it pops right back up to the standard storage tier, and I think there's an extra fee charged with that, and then it slowly drops down. But over time, most of the time you can see some significant cost savings using intelligent tiering. And AWS sets up intelligent tiering for all of their AWS open data buckets. So all of their data that they host and govern and set up themselves to provide to the community, they automatically turn intelligent tiering on. This is what they use internally. So it's a very good option. There is what I just said, the AWS Open Data Program. You can get sponsorship for your own data sets if AWS thinks it's interesting and valuable to the community and has good data gravity. So that means it's a good data set they expect people to use and want to use in AWS. So it's going to bring people to AWS. So they give you an initial 2-year agreement, and then every 2 years they reevaluate whether they want to keep sponsoring your data set. It's a really good way to get free storage. and only storage. You can't do other things there in that sponsorship, but you can store a lot of products for free on AWS's dime that way. So we've had good success on certain projects using that. It's just an application. You can click the link in these slides to get to that application. On the compute side, what you need to know is how many vCPUs or GPUs are you going to use, how much memory, and how much disk are you going to use. That tells you what instances you can use or what or how well Fargate is going to work for you. Once you know those, you can predict compute really well, and you can start to think about, well, okay, how do I change my workflow? If I can reduce memory here, I can get below this threshold, which means I can use a cheaper instance. Or I want to use the fast SSDs on these instance types, but I use too much disk, it doesn't fit there. So I either need to mount a volume, which I have to pay for, or I have to figure out how to reduce disk usage in my workflow. So looking at these and tracking those is kind of how you can benefit from reduced compute costs, but sometimes those are significant engineering efforts. One of the first places to start is, did you lift and shift? If you did, there's probably good reductions you can do without a ton of engineering effort. If you're already pretty optimized, this is going to be a diminishing return. AWS also does provide cloud credits for research. Another application you can say, you can apply it through and say, hey, I'm doing this cool thing. It's going to benefit the world this way. I need this much money for it. And they may give you just cloud credits that you can apply and use and run. And we've seen some good success with that as well on some projects. And also occasionally NASA and NSF hand out cloud credits via small grants and sponsorship type things. The other costs are largely a result of institutional security postures, at least in like typical science workflows. So they're like security monitoring things and this kind of stuff that gets imposed on you and likely don't have much room for you to modify or change or that kind of thing. And depending on how they've set it up, can be pretty heavy on intermittent science workflow. So if they do a scan of every EC2 instance that's fired up, that costs money. And if you're firing up and shutting down and firing up and shutting down a bunch of them over time because of intermittent stuff, you can actually see pretty high charges in this category. So working with your institution to say, hey, can you wait like 2 hours before you scan an instance? Because like, then it's a long-lived one that actually matters. Those kind of things can help reduce those kind of charges, but not screw up the security posture too much. So you might have room to work with, but they're going to be working with the security team and changing an institutional policy. So those are unlikely to be cost-effective wins in terms if you count time. So for managed workflows, like these kind of science workflows I mostly talked about, data and compute are predictable. They're going to be the bulk of the costs. You can do very well with budgeting on them by focusing on them and optimizing by thinking about better ways to organize that. Spot pricing is great. If you can use on-demand budgets, you can save, or on-demand instances, you can save a ton of money. You can cut your compute costs by up to 1/3, but you've really got to be locked into workflows and interruptions and handling them well and resilient to it. So that's the caveat there. So a little bit access control and management. IMA is where everything breaks all the time, sort of a thing. You deploy a new service, it doesn't quite have the right permissions, deploy fails, things don't work. Iterating on IAM stuff is very common. It's also really important because that is how you don't run up bills or let people accidentally do things. So you want to adopt this least privileges policy that makes it so that things that you don't explicitly want to happen can't happen, because anything that happens in AWS costs you money. AWS provides managed policies for convenience. They are often more broad than you want, but they at least definitely help reduce the privilege window to just the services you're using. So start with those and then kind of reduce from there. One of the fun caveats with AWS is permissions are on both sides. I can have like a bucket can grant me permission to write it, but I also need permission to write to that bucket. So you have to do both sides of that transaction to cross permission boundaries like that. So sometimes you need to work with other teams or other accounts to get the permission set up the right way. Yeah, permissions and dealing with permissions is lots of small iterations, deploying, failing, tweak, deploy, fail, tweak, deploy, fail. Oh, didn't have that permission, add that specific permission. Oh, didn't have that permission, add that specific permission. So to get to a good least privileges space, it can be quite a bit of effort to get there. Once you're there, it's usually pretty easy when your main stack's developed to kind of maintain that posture over time. You should generally follow best practices. There's a link to AWS IAM best practices. That's going to look like use temporary credentials, not long-term access keys. Make sure everybody has a MFA device and regularly rotate any long-term keys to reduce exposure threats. It's also a good idea in CI/CD pipelines to scan for accidentally committed secrets. So the actions that we've hooked up to that Docker container as part of the cookie cutter do use TruffleHog to search for committed keys. If you've committed it to GitHub, the immediate action is to go delete or rotate that credential. That's the first thing. And then you should figure out how to remove and edit that from the Git history, but go and just take care of that credential, remove it, don't let it work anymore. So yeah, IMA is really important. It's also very frustrating and very opaque often.